This video will cover the exercises and activities for Tuesday. At the outset here, I want to mention the new effort that we will be adding, which is data collection, and there will be 3 components to that on each day. The goal is to have the TA team handle most of those responsibilities to free up the instructors. One component of that is the collaborative wall, where we will be asking a different question every day for the students. And the goal is for them to answer either on post-its or on a poster boards where they write directly, or in some other type of mechanisms that can be captured at the end of the day by taking a picture of it. The other aspect as well is to document what happens in the classroom. You saw the website and you were able to see the many different components of the class based on the video photos that were captured of the classroom. So we want to do that every day, and again we will be asking the TAs to do that, and the goal here is to capture the magic moments, if you would, throughout the day, especially when students are explaining a concept or giving a presentation, or one of those points upon which, as you're moving throughout the day, just strikes you as a good opportunity to capture what's taking place. We will follow this up with the mechanisms through in which that we will use for us to do that. As you start your day, the very first thing that you will do is that you will create teams just like on the day before. However, in this case, you will do it manually. The goal here is to get balanced teams where you don't have teams that are overly strong or overly weak. And this is something that your TAs can do in the 30-minute block before the day gets started. Once we get started with the day, the first activity will be the magician's trick, the binary search that we've demonstrated. This is one that you can do before the class and that you'll want to practice with your instructors that morning or the day before in the evening as you think about the next day. You can then ask the students to try to figure out how it is that you do the trick, and after some time or some discussion that you have with them in the classroom, you can give them the answer. The demo and solution here is meant for you, the instructors, and the teaching assistants, not for the students. You can demonstrate this for them, then they can try to replicate, and they can have some of those activities on their groups, and to try to prove to each other that they can do the trick, and then the group itself will select a champion to represent the groups. Now after that, you will be selecting a winner for the class, and the groups will get to go head to head. As you know from having practiced this activity, there are many places in which an error can be committed. And so this leads to tension, this leads to nervousness, and this leads to a pretty close attention as the competitions are going on. Last year, this was a lot of fun that we had on this activity. Now the next activity of the day, there will be a theme of binary throughout the day, is the one that I'm showing here, which is binary counting. You can show to them this classic t-shirt and see if they have the MIT kind of humor. From there, you can walk through the concepts of binary counting. You can use these diagrams. I've provided some links to where these pictures are. I will also put this specific deck within Tuesday. And if you are rusty or haven't done it before, you can see here what the concept is. Each finger is a power of 2, which means that if they're on, meaning the finger is up, each of them has a value, and the number that you get is by adding all of the on fingers. If they're off, then it's a 0 for that value. And you can see here that within one hand you can count to 31 using all of the different fingers and all of the different positions. They always snicker around, some of the ones that look more offensive. And then, of course, 6 is the one that's very much peace and love. Now once you're done teaching binary, you can ask them to work in groups within their groups and to demonstrate to each other that they can in fact come up with a number once they quiz each other. So you can, they can propose an 8, a 6, a 4, a 5, etc. And they can see how fast they can each come up with those numbers. Now, once everybody has gotten a mastery of this, you will hold a competition. This is the only competition that we hold during the workshop that is by individuals. That means everybody gets to participate. There is no hiding from this one. Everybody goes in pairs up to the board, and whoever wins remains up on the board. Whoever loses gets to sit down. And you can see here a competition throughout all of the participants in the class, and you will get at the end a champion. Just as when it came to the card trick, there's a lot of mistakes that can be made earlier on when people are rusty, and so that leads to a lot of excitement and and laughing and nervousness and so on. In the last activity of the day, they get to create a binary clock. They get to use the knowledge that they've applied in the previous competition. And for this exercise, you do not give them any information other than what they have learned when it comes to representation of decimal information or numbers in binary form. So this is a problem that will make them think. You can give them some time, after which you can start to give them some hints if you see that they're stuck. And after they've worked for some time, you and your TAs should verify that technically the part of the representation of numbers is sound. Some of them struggle more than others. Others can move through it pretty fast. And at the end, you will ask them to present a solution. As they tend to do, most of them will start to work graphically. They will first move through the technical component of the problem, and once they feel confident that they know how to do these representations, then they will start to work on the design, and then followed by the aesthetics. This was a very successful activity last year, and you can see here some of the binary clocks that were created. Those 3 activities will cover the morning, and so after that you'll move to your afternoon. In the afternoon, you will cover the core components of most languages. We will do that with the language of the browser, which is JavaScript, and we will move away from the declarative programming that we did in the first day. You will do similar things, however, you will do them all in code. And so the components that you will cover are variables, arrays, conditional statement, loops, and functions. And you can tell the students that although we're doing them in the language of the browser, they're really the same core components that all languages have, the Turing complete language components. In this session, we will be working directly on the console of the browser. If you have not used that before, it is part of the Chrome browser, which all of the machines will have. And if you navigate through the menu on More Tools, you will find the link there to the console. There are many other components as well, including a debugger. If the shortcut tool, as you can see there on the Mac, is Alt Command I. I believe on the PC is Control Shift I, but this is something you can confirm if you are on a PC. As you can see here, I have opened up a blank browser page, and I've opened up the console as well. I'm then going to go ahead and load up an HTML file, and let me go ahead and show you what's in it before. As you can see there, it is an empty file with the exception of making references to 2 files. The first one is called Magic and the second one is called Ball. So I'm going to go ahead and load those 2 onto the browser as well. And I'm going to go ahead here and show you that Ball has nothing at the moment. So the very first thing that we're going to do is that we're going to create a variable here on the console. We're going to call it Ball. This is simply a declaration. We're then going to do the same thing that we did before on the previous day where we created a div, which was a circle on the page. However, we're going to do that now programmatically. And so I've predefined a function within the Magic file that will do that for us. So I'm going to go ahead and enter here create. And after I had that, I should be able to see that on the browser. So I'm going to go ahead and do it. And I got an error. Yes, I can see the problem. I have not loaded the browser. I have not loaded the HTML into the page that pulls in all of the JavaScript, so I'm basically working on a page that has no code, none of my code. So I'm going to go ahead and bring ball onto the browser. As you can see there, there is nothing on that page. As you remember, the code here for ball is doing nothing. So I'm going to go ahead and create the ball, and then I'm going to assign to ball the div that will be created within this function. So once I do that and I navigate back to the page, you can see there that I have this little ball. And then I'm going to show you a number of functions that I have created in order for you to demonstrate functionality in calling functions with the students. So the very first one is we can change the color of the ball. So I'm going to go ahead and move this down so we can see it. There's color, and then we're going to pass in the div, which in this case is called ball. And you can see there that the color did not change, and that is because I got the wrong syntax. So I need to specify the color in RGB, so that in this case I'm going to go for red, and so I'll say 200 and I'm going to make 255 so I can get an intense red. And as you can see there, the color changed on the ball. Let's go ahead and move to another function. Another thing that you can do as well is you can move your ball. So I'm going to go ahead and do that. Move ball, and I'm going to move it by 50-50. That is 50 horizontal, 50 vertical. And the ball just went off the page because I moved it over, right, by exactly how wide it is. I can also change the color in a random way. I'm going to go ahead and clear here my instructions because I'm running out of space. And we can enter here color random and give it the ball. And you'll be able to see there that the colors changed on the ball. There are other things that you can do, like change the z-index. In this case, it doesn't matter because we only have one shape. And you can even repeat a certain amount of movement. And I'll show you here what's taking place. You should be able to see the ball moving, and there it goes. Now, that was some of the basics, creating a variable, calling functions, and I've shown you here all of the functions and the signatures that they have. The next thing that we want to do is we want to cover loops. While loops are friendlier when it comes to seeing them for the very first time, there's also a conditional statement that you should explain. There are other things that at time will trip people up. So for example, saying counter plus plus as opposed to doing an assignment and then an increment. But here is a pretty compact representation of that. So in this loop here, we're going to create a number of these balls using the create function and the code that you see here. So I'm going to go ahead and reload the browser page here. Let me go ahead and get to it. And then I'm going to paste some code onto my browser. And the code is the same one that we showed on the page. As you can see here, there's a counter, and we're moving through iterations, and on each one of those we are creating a ball. So I'm going to go ahead and hit return, and as you can see there, we got a bunch. Now here's the fun type of thing where you can start to, depending on some conditionals, vary the size, or you can simply just create a lot of them. Go ahead and create 1,000, and you can see there that that starts to be pretty fun. Even with just the functionality that we've covered so far and some of the conditionals, you could start to do some pretty interesting things. Now the next thing to cover is arrays, and you can present this as a list. This is something that is used in everyday life, and this is the syntax to do arrays within JavaScript. You can see there that in the very first line I am declaring an array, and the subsequent 4 I am simply pushing balls onto this array. Now once I have them, you can see here that at the bottom I manipulate the color on each one of those. So let's go ahead and demonstrate this here on the browser. I'm going to go back, I'm going to reload the page, and I'm going to paste the following code. And as you can see there, it is the same code that's on the slide. And when I hit return here, the balls are going to be created, and then we should start to see some of the changes in colors. I think I moved too slow. Let me go ahead. I should do it in 2 separate steps. This is simply because of the rendering in the browser. So let me go ahead and break up into 2 steps. I'm going to go ahead and remove this part. And so I'm first going to create a number of shapes, and then I will vary their color using a loop. And you can see there that the colors are changing on each of those balls. Now the next exercise is the exercise of the painting, the Mona Lisa. This is one that could be made pretty challenging, but the recommendation here is to start off simple and get everybody a win before you move into the more complex components of it. You can give them the length, and you can give them, or you can tell them how to access the properties of the objects. In this case, for example, here the X, the Y, and the color. And then they should be able to create a loop that gets access to this information and that can then put every dot on the page. It is very little code, but there's a lot of things going on in it. There are conditional statements, you're accessing array components, you're accessing properties on each of those balls, and you are creating them, all of them at the same time. So let's go ahead and take a look and see what this looks like. The code for this is in the folder Painting 01 solution, and so I'll start off by showing you the solution. And I'm going to go ahead and drag and drop the ball folder onto the page, and as you can see there, all of that information that was structured in the array in a way that you could pull it out and just draw across the screen has been pulled out, and all of the different colors together have created the picture of the Mona Lisa. Now if you look inside of ball.js, you'll see the solution, which is the same code that we were just showing on the slide. Now a bonus level, or taking it up a notch, would be to take a look at the code that actually created the array, within which you could actually insert the function that creates the painting. As you can see here, you can start off by prompting them in an understanding of how the data should be organized in order to create the painting. So in other words, there should be a certain amount of spacing that you put in order to get one circle next to each other without overlapping, and that at a certain level you have to return, if you would, and so you're going across rows and down columns as well. And you can see here what that solution is. So let me go ahead and modify this code a little bit and show you how that could be done, and as well as mention that this is an opportunity for those that get finished pretty quickly to try to do manipulations. And the manipulations could be those of the graphics transformation matrix, but in this case they can do it by hand, and if they do it right, you can start to have rotation, you can start to have skewing, and other nice little things. So in order to do it by hand, I'm going to go ahead and delete the code from ball.js. I'm going to go ahead and save that file. I'll then open the magic file, the ugly one. Let me go ahead and pull it into the capture window, and I'm going to go ahead and move all the way to the bottom. And as you can see here, this is the part in where you can create the balls on the fly, and I'm going to go ahead and comment out the data array, as we will not be needing it. So I'm going to go ahead and save that, and I'm then going to drag and drop the file onto the browser, and I'm going to go ahead and do that now. And you can see there that we get the exact same solution. This approach requires you to understand the structure of the information, and it requires you to understand how to lay out all of the balls, know when to start a new row, and how to move through the columns and all of the rows. So this is a part for those students that are a little bit ahead of the rest and that want to challenge themselves. By the time you're done with that, it'll be time for the project. Here is the link again to the documents and to the code. And there's also there a pointer to the milestones document. This was created by Sylvia, and she put in there some milestones that all teams need to be meeting. Otherwise, there's some confusion as to what they should be doing every day. Once you're done with that, then you'll move to the end of the day tasks, which are the reflections and the data capture. For the TAs, you should capture the collaborative wall. You should also do the instructor reflections, which of course should be done by the instructors, and we'll follow up with more guidance on that. We will dedicate a video to it, a short one. The TAs should submit their own reflections, and the students should be reminded to do their 1-minute capture or video at the end of each day. So that is the end of Tuesday.